Hey guys, I want to share some tidbits about how I refactor my code and how I use functional programming to make things nicer. So ideally, I have an amazing developer environment with all the tooling. I have amazing tests, and I can make daring refactors to my source code or try to write the best code I possibly can. So here, the feature is a search filter. So we can type something and it can be uh, any part of this, right? Any part of these objects properties, right? So anything will work. So that's the thing, right? Like search me for anything. That's the search filter. Um, what I did with this application is from the book. So let's say we have a heroes entity, right? Then it's been written a certain way, but it's a very similar 99% same way test. And we have, let's say, a boys entity, and you their implementation may be slightly. So maybe like I'm trying some Ramda over here versus doing imperative programming on the other side. So that these are the components. Now let's take a look at the code. So on the left side, I have the hero list, and on the right side, the boy list. And when I go through the one on the left, I always have a hard time wrapping my mind around this search and filter functionality. So it's basically these three functions. And at the end, it comes to this. And this part is similar between the two, and we don't have to talk too much about it. But let's look at the important parts. Search exists. Basically, if any property exists in that search field, just give me a boolean, just give me true. Otherwise, don't give me that. And it is kind of hard to read through, right? Like search property, okay, we have to make that to lowercase, and then if that's an index of the search field, then give me one, otherwise don't. It's hard to read. I don't like that. So I thought, okay, can I write that in a better way around that? Index of maybe familiar. Basically, is this item like give me the index of this item in given this data. So Ramda data is on the right side all the time. So this is the data. That's the whole data. So that's the search property. And then this is we're looking if this guy is in this guy, right? So at that side, tool over is basically to lowercase, but it's kind of nicer and easier to reason about. And I think the Ramda version is so much nicer to read and work with. Nothing to get scared in there. So the second one, that's actually where I have the harder time reading the code. Uh, so we have data, we have the search field, right? And then we want to return the data in which the search field exists. So we take the data, filter through it, and basically we have like a hero array, and then each one is a hero. And that hero, of course, the hero is an array of objects. And we go through that, and our predicate is if that exists, right? So, I mean, it's okay. It's imperative. I get what's going on, but it's not very nice, right? I always have to read the code again to remember what it's doing. So here's a random version. And don't get scared of the query and the Python. I'll explain why they're there. But think of it this way. So we have the item, right? That is basically this array. Ah, with Ramda, right? What if we could pass this data later? Right? We don't have to worry about it, right? So what if that would be possible? And before that though, before we get there, right? There's this part over here that could be factored out, right? That would make things easier. So instead of having to go to the object values and find it and then pass the predicate, what we could do is say, okay, this is our item, right? We're gonna pass it at the end, and then we're gonna take the item, get the object values out of it, and this is what exactly that does, right? This point. And then the find is exactly the same function we have here, right? Which is it's just round the find and round the values, but this is object values. This is your regular array find with your predicate, sorry. The only difference is that we're getting the data later and we're piping that data through values first and then the find predicate. Same thing that we did here, but it's just nicer to read. Now the query here, that's basically for us to, usually query is if you have a function like this and then you query it, it can be something like this, right? So you can pass the arguments separately. But in this case, what it's enabling us to do is basically draw circles around TypeScript, which I love to do all the time. Yes, this works without it, but okay, TypeScript, just chill out. We know what we're doing. So we'll carry that. Search properties then becomes much easier to reason about, right? Because this part became its own function. And since we're using pipe and Ramda, we can worry about the data later. So we only have one argument here, search field, versus the two arguments there, because data will come later. So what if you didn't have to worry about it? So you would just get whatever's coming in, filter, just like you're filtering here, right? So the same filter. And then this whole thing became one function called that. And then we just use that function as a predicate, the filter. How they get used in the bottom part, so yeah, the search field, that's the same thing. And basically, I wanted to make this a little clear, but effectively, we just passed that argument with two separate arguments. So we could just put this guy here, but renaming it like that makes it a little easier to read, right? So otherwise, I hate variable assignments, but when it's for readability, sometimes I like to make concessions, right? So this is easy to read. So round version, right? Left side, I mean, I really like the right side. I think it's also easier to debug because you could just tap something and then you could go to town with it, whatever you want to debug, right? So we could do that. All we would need is just tap. That's it, right? And yeah, stop complaining. We know what it's doing. Oh, we have to return it, right? Because and then that would allow us to console log and whatever in the code. Anyway, so now the secret I want to share is that code. I mean, no, but I don't think anyone writes code like this on their first try. So it has a way of evolving to that. So what I really like doing is whenever I have some sort of like a mini code like this, I like to prototype that using Quokka, which gives immediate feedback. So if there's some data that we're working on, I just copy that data, just a variable. If there are some types needed, fine, I'll copy those too. Right? And here is the original version of that code. And I can immediately play around with things here and get instant feedback. Oh, that didn't work. Okay, try this. That didn't work. Try this. Like so, for instance, instead of find here, we could even do filter. It wouldn't make a difference, or would it? Yes, it would. So anyway, you had the point is you get instant feedback. Now, when rewriting in Ramda, right? Again, it's just trying different things and prototyping. Like for instance, this is one version of things I came up with, and then this version I liked better, right? And then since I have the final code, different varieties of it, I could immediately see, oh, should I do it this way, for instance, if I use this one, right? Would this work? It looks like it's still working, right? It's the same thing. So whenever you're prototyping, whenever you're refactoring, I think Quokka is priceless. I just put it somewhere so that you can get fast feedback and play with the code versus using that code to render things in a component and then make sure that your test is still passing. Anyway, so to wrap up, learn Ramda because if you look at ES6, what's coming, you will be seeing features similar to Ramda pipe or other cool things from Ramda. If not in 2025, within the decade, JavaScript will, in my opinion, will look a lot like Ramda. So learn FP. It will go the FP way. Learn FP and learn Ramda. So that's advice one. Advice two, use Quokka to quickly prototype your code because since it gives you this instant feedback without having to run this file and get that, you can work so fast and get results. And of course, have amazing tests that so that you can do these kind of tailoring refactors. Like I have 100% code coverage. You don't have to have 100, but with end-to-end and CT combined, you can have over 90% easily. And once you have that kind of a thing, you can do try things that you've never tried before, and when they work, it's pretty cool. But that's all I wanted to share.